Alright, let's go through some examples here. And so we're just going through one example, but this is the sort of test question where I tell you, oh yeah, you just have like 7 questions, but it's really like 28 because there's like, parts A through D for each one. So we're going to go through one of those, but just one example, okay? So here, I have a vector field just xy, and we know that divergence is 2. Okay, great. So that's actually, tells us that the divergence is positive, right? Okay. And specifically it is 2, okay? And we know that the divergence tells us the infinitesimal flow. And I should say net flow. Okay. And so now, number 3 is kind of interesting. So it says, well, really the double integral over a disk, that is, so the unit disk for the divergence. So I'm going to do my best to freehand this. And so let's see, we have something like this. Well, okay. Okay, so this is our unit disk D, and we can think of it as shaded in if we want. Okay, so there's our unit disk D, and I'm curious, what's the double integral of the divergence? Okay, well, I'm going to let you think about that for a second. Okay, I personally think that it's going to be positive. Okay, because, well, we know the divergence is positive because it's 2, right? And if we integrate over that, and we're thinking it's, and so I guess really we're thinking it's infinitesimal net flow at a point, right? And now we're doing it over an entire region. Well, if we add up things that are all positive, we should get something that's entirely positive. So really what this integral should tell us is total net flow over the region D. Okay, so that's interesting. We can actually do a double integral of the divergence. Okay, so now we're going to look at kind of the same thing in a different way. So you notice in the diagram we still have the same vector field. Okay, great. And now we're looking at the boundary of that disk only, not the interior. And we're saying, okay, let n be the unit outward normal vector. Okay, so then the first question is, what's the sign of the vector field dotted with the normal vector? Okay, well, I claim it's positive. Why is it positive? Well, that has to do with the dot product, right? If we think about the dot product, okay, they're vectors in the same direction, so they should be positive. Okay, and so what does this really capture geometrically? It's telling you if the VF, the vector field, flows out at a point, and the point would correspond to wherever this unit normal vector is. Okay, and then now I'm kind of curious. Okay, well now if I can look at the line integral around the boundary, or over the boundary of this quantity, and so would that be positive or negative? And again, I think it's positive, okay, mainly because I think you're looking at kind of, well, maybe I shouldn't spoil the party bit here, but when we look at this line integral, what it's measuring is total flow across the boundary. Because what this unit normal vector is doing is it's a vector on the boundary, right? And so we're looking at kind of flow out of the boundary, or sorry, flow out of the region, which is to say that we're at some point we're looking at when the vector field crosses the boundary that we have set up. Okay, and so that's going to be the conclusion of this, but kind of just looking big picture at what we did here is we looked at flow, or total net flow in a region, right, with this double integral of the divergence, and we said that was going to be positive. And then we also thought about, okay, well, if we look at just the boundary instead of the entire region, and we look at the line integral of the vector field dotted with the normal vector, which is, again, that whole thing is measuring total flow across boundary, we notice that that's positive too. So now I'm kind of curious, if we talk about total net flow over a region and total flow across a boundary, is there a relationship between the two? Maybe, maybe not, or maybe these are just interesting things to study. And so I think that will segue nicely into what we're going to discuss in the next video.